Hello everyone and welcome back to another video. And today I want to talk about 3D printing again. Not lightweight or seaplane components specifically, but just 3D printing in general. Because as I've now been involved with this topic for a couple of months, I have learned quite a lot, and I have now reached the point where I have actually bought a second 3D printer to start experimenting with it in much the same way as I'm experimenting and modding with PC hardware components. So I felt ready to go out and buy some old basic 3D printer, basically just for the purpose of experimenting around with it. And I'm going to tell you all about it after this message from today's sponsor. Before we continue, I'd like to thank our recurring sponsor, PCBWay. PCBWay offers professional PCB manufacturing and assembly services of all shapes and sizes, whatever you need for your project. You can quickly get a quote by just telling them some basic information about what you need, and if you like what you're seeing, you can upload your design files and go straight ahead to payment, fabrication, and then shipment. And even if you don't need a PCB-specific project, you can still find some very good options here, because PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and even injection molding. If any of this sounded interesting to you, then please go ahead and give PCBWay a try. I have bought this old original model Ender 3 for 80 euros, which, if you really think about it, is a really good price for what you get. Now, the original Ender 3 by no means is a very advanced 3D printer, but it is one that you can get some pretty good quality prints off, and for 80 euros, that's essentially a steal. To put this into perspective, my Ender 5S1 plus the Clipper-equipped Sonic pad I use it with cost 500 euros together, and I got the Ender 5S1 on a discount. It normally costs even more. So is the Ender 5S1 over 5 times better than the original Ender 3? No, of course not. The Ender 3 is definitely the better value option here, though I have to say that as your very first 3D printer, an original model Ender 3 is probably not a great pick, because it is missing some fairly basic features that you pretty much always get with a newer model 3D printer these days, and those features make using it a lot easier. So obviously, I'm not going to keep my Ender 3 as is. Now, I have run a couple benchmarks through it, and we'll get into the results shortly. And I do have to say that the quality of a bone stock Ender 3 is surprisingly good. But there are some issues, and I do want to fix them, and I also want to make using the printer just a lot more convenient by adding things like automatic mesh bed leveling, an easier to use print bed, and the capability to also install Clipper firmware onto the thing and not just using the bone stock, fairly old Marlin install that Creality ships with them. But first, I think we should get into some basics about 3D printing. This YouTube channel is mainly focused on PC hardware components, not 3D printers, so I don't expect you know any of the terminology that we're going to be talking about today, so let's do a little crash course. My main workhorse reliable printer is the Ender 5S1, which I've purchased a Creality Sonic pad for to update its firmware to Clipper. Now, Clipper is currently the newest and best firmware for 3D printers that you can find. Marlin by no means is a bad firmware, but it is an older firmware, and Clipper just does things better now. It is just the next evolution of a new 3D printer firmware. Actually, most 3D printers these days just ship with Clipper pre-installed. My Ender 5S1 did not, so I had to separately get this Sonic pad and install it myself. Now, the Ender 5S1 is a fairly expensive printer if you compare it to some other budget options that can get prints of roughly similar quality. That is because the Ender 5S1 is what we call a Core XY printer, whereas most 3D printers on the market, including the old Ender 3 I bought, are something that we call an i3 style. Now, on a Core XY printer, as you can maybe guess, the printhead moves in the X and Y direction, and the bed moves up and down in the Z direction. This makes sure that the weight moved around by the X and Y axis always remains the same, so you can always run the printer at the same maximum speed. Whereas on an i3 printer, where the printhead moves on the x-axis and up and down on the z-axis, and then the print bed moves on the y-axis, the weight and load on your y-axis with the print bed changes as you print the part. And that's significant because most of the fast movements of your printer are on the X and Y axis. That is why Core XY printers can typically print faster and with higher accelerations than i3 printers, because they don't have to move the print bed and the printed part around with them. But there's also drawbacks. A Core XY printer needs a much bigger and more sturdy frame, which of course means the printer is more complex and more expensive. And for the typical user, a Core XY system is usually not needed. You can go for an i3 printer, they are still pretty fast these days, even compared to a Core XY. I specifically chose to go for a Core XY printer because I want to print with lightweight PLA for my RC plane projects. Lightweight PLA is a bit of a special material. It is designed to foam up, and therefore you can't prevent things like stringing. The only way to minimize it is to move around very quickly whenever you are not printing, something that a Core XY printer is uniquely suited to, which is why I chose the Ender 5S1. Now, compared to the Ender 5S1, the original 2018 model of the Ender 3 is very basic but functional. You can do pretty much everything with an Ender 3 that you can do with an Ender 5S1. It's just going to be slower and your quality is going to be somewhat worse. It would actually be very complicated to go into all the things that the Ender 3 doesn't do or the Ender 5 does. So I guess the best way would just to make a short list and then explain things when and if they become important. The Ender 3 doesn't have automatic mesh bed leveling, a removable magnetic print surface, a 32-bit control board, a direct extruder, linear rods and bearings for the z-axis, a touchscreen, or an all-metal hot end. The Ender 3 also requires you to use a micro SD card, which is frankly a quite strange decision because there is enough space to fit a full-size SD card reader, and I think I speak for everyone when I say that micro SD cards are just worse than full-size SD cards from a usability standpoint. They are so small, you can easily damage them, easily lose them, and as is the trend with smaller connections, they do probably also wear out faster. You do also have the option to connect the printer via USB to your PC and then use a print server program instead. I tried that with Kira's built-in print plugin and it worked until it didn't, and I suddenly lost the USB connection, the print stopped, and I never got my PC to recognize the printer ever again. So I had to run out and buy a microSD card because until that point I didn't actually have any. But let's talk speed and quality. Speed-wise, the Ender 3 is roughly half as quick as my Ender 5S1, at least with the profiles that I've come to use them with. I typically drive my Ender 5S1 at a print speed of around 150 millimeters per second, whereas the Ender 3, I pretty much don't trust any farther than 80 millimeters per second, which is just over half the speed. Now the Ender 5S1 can actually go significantly faster. I do have a profile at 250 millimeters per second that does work. However, quality starts to suffer at that point and I wouldn't use it for any large, very detailed prints. That one's just more for small or less detailed objects. So speed-wise, the original Ender 3 isn't very good, but that's not really a problem in my opinion. The printer was never meant or marketed to be quick. It was meant to be cheap and produce prints of okay quality. And that it does. If we take a look at the very first print it ever produced after I'm now owning it, well, apart from the part where I lost the USB connection and the print stopped, it is decent quality if you don't look at the lower layers. Yeah, that horrible over-extruded mess isn't actually the printer's fault, it's actually my fault. Because when I was purging filament from the printer, I set the flow to 300% to get the extruder to push more filament out of the hot end, and I just sort of forgot to reset it. And once I realized my mistake and set the flow back to 100%, the printer produced pretty decent quality. Up until it lost that USB connection at least. Now, the biggest usability problem with the original End of 3 is the bed leveling. Like I said, there is no automatic bed leveling at all, and so to get a good first layer, you completely rely on your Z limit switch being placed at the correct height, and those 4 massive screw and spring combinations to get the 4 edges of your bed to somewhat the same height, using the good old paper trick. Now this works. I did level the bed once, and now it works. But before that, I had to do a bit of trial and error, which resulted into some funny looking prints where the first couple bottom layers just don't exist. This was because the springs and the edges were tightened too much, which actually bent the middle portion of the bed upwards, and so the nozzle was essentially blocked, and the rather weak extruder setup just started skipping, and no filament came out of the nozzle until it rose high enough. So we ended up with this benchy that looks pretty decent, but just doesn't have a bottom, which is quite funny to me. As it turns out, the rather weak extruder of the original Ender 3 actually kind of works out in its favor, because if you have a problem like this where you are too close to the print bed, rather than digging into the print surface and squishing filament out to the sides, your extruder just starts skipping and just waits until the nozzle is high enough to start extruding. Not that that's a feature, I think that's just an accidental nice to have, more like, but something that I'm not going to keep as is. Now, there's one other thing about the original Ender 3 that is somewhat problematic, and that's the extruder setup. Not only does the actual extruder gear that grabs the filament not have that much pressure and starts to skip easily, the Ender 3 also uses something known as a Bowden extruder, where you have an extruder motor that's tied to the frame, extrude filament through this long PTFE tube, which is then pushed into the hot end. Now, there's nothing wrong with the Bowden extruder in principle. Actually, some of the fastest 3D printers in the world use a Bowden extruder because it makes the print head lighter and you can therefore move it around faster. However, Bowden extruder setups do have a quality penalty, and they do have some failures that can appear that direct extruders just kind of don't have, which I guess is why most 3D printers these days do use a direct extruder setup, like my Ender 5 is one. And that is that if your PTFE tube just slips out very slightly, well, you're going to start having under extrusions. And that is pretty much what happened. The printer produced this first half benchy and then the second one with the missing bottom part, and after that I started getting issues. I printed this lattice cube, and while it did finish, which was sort of impressive because as far as I know this is a pretty challenging print that's not supposed to work on cheap printers, the layers just look horrible compared to what the Ender 5S1 produced. And this wasn't apparent on the benchies. Their quality is very slightly worse than the Ender 5S1 still, but very passable, and there weren't these massive obvious under extrusions. I'm not actually entirely sure what the problem was. After this I just took apart the hot end assembly to look if I had a clog. I didn't, so I just put it back together. I then cleaned the X-axis V-roller and V-slot, and also noticed that the X-axis belt was slightly looser than it should be, so I tightened it back up. I don't know what of that solved it, but after I did this, I no longer had the under extrusion problem. So now that the printer finished the lattice cube, which was kind of impressive, and I had fixed the under extrusion problem, I thought it was time for a really, really heavy test. So I decided to print the torture toaster, which on the end of 3 is a 12-hour print. Yeah, the Ender 5S1 finished its toaster in about 6 hours. And I must say, the toaster came out great for both of them. Looking at it, it does seem that my Ender 5S1 actually has a Z offset that's a little too low. You can't really see the individual lines on the bottom layer anymore, and it's a little squished out. Now, that's a little bit of bad setup on my part. I haven't really optimized the Ender 5S1 to produce super high quality prints. Again, I mostly got it to print in lightweight PLA for my IC plane projects, which means rather large, lower detail parts out of a material that, because it foams up, just kind of fixes its own quality issues somewhat. So I never really had a reason to super precisely dial the Ender 5 in. Looking at the Ender 3 toaster, that one has pretty good looking bottom layers. It's maybe a little bit too far, a little bit under extruded, but that's really just a visual thing. The feel of the bottom layer is just right. It's basically perfect, which I'm surprised that I got that after just one serious try to get the bed level, because I've heard so many horror stories about the Ender 3 bed being hard to level and unleveling itself mid-printing. Now admittedly, I haven't printed that much with this printer yet, and I am going to upgrade it, so that's no longer an issue. Other than that, it's obvious that, again, the Ender 3 has slightly worse quality overall when it comes to the layer consistency. There's just a few more layers that kind of look like they're a little bit over extruded or a little bit under extruded, or just otherwise not as precise as what the Ender 5 produced. But again, that's a minor thing. I think overall both are fine. Looking at the overhang test, both printers successfully completed all the overhang tests, though when you look at the 80-degree test, the Ender 3 was clearly starting to struggle, whereas the Ender 5 still mostly held it together. Looking at the logo, we actually see some slight under extrusion on both of the samples. Again, the Ender 3 is slightly worse, but it's not a massive difference. Looking at the finish of the top layers, I think the Ender 3 actually did a better job than the Ender 5. Now, this is a consequence of me having recently switched to Prusa Slicer from Cura, and while I'm getting overall better quality prints out of Prusa Slicer, there is one thing that's missing from it, and that's flow control per feature. In Cura, you can set a specific flow value per feature, like walls, top layers, bottom layers, or infill, whereas in Prusa Slicer you just have an overall extrusion multiplier, which applies to everything. While doing my first test prints, I noticed some slight under extrusions in the walls of some prints on my Ender 5, so I increased the extrusion multiplier, but because I can't increase it for just the walls, it increased it for everything, which actually led to the top layers having these slight over extrusion artifacts, which the Ender 3 didn't have. Now this is probably just because the Ender 3 extruder has a slightly lower flow rate just set up printer side, since all of these prints were done with the identical model and identical print settings apart from printer specific things like speed and retraction. Now let's actually get to something that I've had a problem with on both of these printers, and that's the clearance tests. Both printers horrifically failed all of the clearance tests, and I'm fairly sure I know why. I think, again, that's because I set that slightly higher overall extrusion multiplier in Prusa Slicer, which probably just led to, again, slight over extrusions in places where I normally wouldn't want them, which fused all the clearance samples together. So that's a fail on my part again. I will probably have to fix that. Other than the clearance samples, all the moving parts came loose though, and all the gears, the doors, and of course the toaster part do work flawlessly. I have to say that the Ender 3 one, especially the gears, they run a little bit more rough, but they still run fine enough, whereas the Ender 5 has an overall smoother feeling to it. Again, probably because we're seeing this overall better layer consistency from the Ender 5. So overall, what do I think of the Ender 3? I think it's a surprisingly capable printer for the money that I paid. Don't get me wrong, it does miss a lot of features, and I will be doing some quite heavy upgrading to it to get it to work better. But for what you get for 80 euros, which wasn't even the cheapest Ender 3 I could find, there were a couple people selling theirs for 70 euros. Those people just wouldn't ship to me, so I ended up paying slightly more for one that would. I think the Ender 3 is pretty much unbeatable. It's just that because it is missing things like automatic bed leveling, that I wouldn't recommend it for someone's first 3D printer, especially if you want your 3D printer to just be a printer and not a project. But I gotta say, the price and the results speak for themselves. If you want a low-cost 3D printer and you are okay with messing around with it a little and potentially even want that, then I think this is a great pick. The Ender 3 is an incredibly popular platform with many upgrades available to it, and as you can see by Creality themselves still selling models of the Ender 3 today, models which, to be fair, have been heavily upgraded, but still, the Ender 3 endures until today, and I gotta say, even its oldest variant isn't that bad. It of course can't keep up with newer printers, especially more premium ones, but it's not meant to, it's not supposed to. For what it is, I am surprised by the quality that this Bone Stock 2018 edition Ender 3 gives me. And I'm certainly looking forward to upgrading this printer, as I've already ordered a number of things to upgrade this printer to be faster, more easy to use, and produce prints of better quality. So that will surely be a future video. But for today, I think that's quite enough. Just like with overclocking, there is so many things you can optimize and tweak with 3D printing, which is something that I just really enjoy doing. So there will certainly be more things to come. And my 3D printing adventures and my modding and overclocking adventures might even converge someday, because having a 3D printer is just really useful for if you ever have some random part that you want to use for a project but it just doesn't quite fit, so you need an adapter or some holder bracket. You can just make it yourself. Anyway, that should be quite enough for today, and until next time, goodbye.